I think that I'm going to have to fool around this a little bit, do some copy and pasting, and clean this up after. I'm going to give everyone else the new link here. Just give me a second. Pretty sure this is it. So I'm gonna go on Cynthium and update this. See if it works. Yes, alright, cool. Just have to go back to the old one and tell everyone to jump into the new one. Alright, give me 1 second here. Sorry everyone. Couldn't fix this one. I think what YouTube had done is they've somehow given me a new stream key, so I couldn't use the old one. I'll give everyone the link to this video. Hopefully that works. Yep, looks like it should work. Alright, well, let's start over. Okay. Just give me a quick second here. YouTube seems to have changed the chat settings as well. So I can pop the chat out instead of having it on the same screen as I'm viewing. It's kind of handy. Doesn't throw the chat right beside the video as it used to have for some reason. So it's changed it a little bit. Not sure how I feel about that. So yeah, things have changed a little bit. Just trying to figure things out here. Sorry about all the technical difficulties. I tried to go back to like the old way and see if that would work, but no, I don't think they're gonna let me do that. So I updated the link on the live hack page and threw that in the link in the old chat, the new link in the old chat. Sorry, new and the old, lots of stuff here. Lots of confusing things happening. My bad. But we're not here today to talk about YouTube. We're here today to talk about the Treat-o-matic 2020. And also to change the music somehow died. All kinds of technical difficulties today. Here we go. Now it's working. Alright, speaking of music, we are listening to the copyright-free playlist that I created on Apple Music. So I'm trying to get that list narrowed down to just really good songs and stuff that won't give me copyright claims on YouTube. So doing my best here. Tilt this a little bit. You're not seeing so much of the roof. And yeah, so today we're working on the Treat-o-matic again. This is part 3. I'll give you a view of it right here. So I ran the wiring through this little channel here, put the channel cover on it, and also one back here. And one thing I wanted to test before I went any further and put the cover on is to see if I have enough wire length here so that nothing kind of gets bound up or tight. I do have a lot of slack here underneath these wires. There's tons of length on the wires, so we're okay there, but I just want to make sure that we'll have enough up here. So what I'm going to do is hook up an EZB just to control these motors here. We have servo electronics hooked up that allow these motors to run like continuous rotation servo motors. And so we just have to keep a sharp eye on that we don't bottom things out. So yeah, we will do that. And hopefully others join us over here in the chat, or sorry, in the live hack. It's too bad that this had to happen, but we'll roll with it, I guess. Just keep on going. And if they don't see the link, I guess they can always check this out later. All right, let's do some stuff. I think I'll give you guys the view of all the areas that I'm working with right here, so you can see what's going on. There we go. Just getting a power supply ready for the EZB over on this side. Then we're going to fire up ARC so we can control it. This kind of sounds like Daft Punk, and I'm okay with that. It's one of my favorite electronic bands. Alright, I'll give you guys a view of the computer screen as well. Alright, here we go. So we'll have to change that to the IP address. We'll have to connect to the EZB over Wi-Fi. And we'll have to add a skill. We'll want a continuous rotation servo skill. So servo, continuous rotation, set it up on port D0. Save that. Okay, save. Okay, now we have to figure out, here, I actually can use our web page. Here we go, we got YouTube Inception going on here. Go to Cynthium, Community, Robots. Search for my robot, the Treat-o-matic. Oh, it doesn't show up. So, interesting. Maybe it's because I don't have the full name, but I know it's down here somewhere. There we go. I'm just looking for the wiring diagram. There we go. Okay, so we're looking at the x-axis, so that's the gray and the green wires here. And let's check which one that is over here. Turns out, I guess I forgot that I'm gonna have to solder some different wires. So I will have to solder the gray wire onto the green, on with the green wire on for that motor. So bear with me for a moment, and I will do a bit of soldering here. soldering iron's already primed and heated up and ready to go, so just need to do some wire stripping and make this thing happen. Okay, desolder this wire here. And we'll add the gray wire. We'll tin the gray wire first and then we'll solder it on. So many things here, I don't want to melt things. There we go. So now we can test this out. Okay, we're connected to the EZB. Since it's an analog servo, it moves things right away. Okay, so are we connected to the EZB? I don't know if we are. Yes, we are. Okay. So we'll go over to arc. We'll bring that continuous rotation skill that we set up there. Okay, and so actually we're going to drop these values down because I don't want it to go real fast. So I actually wrote down 87, perfect, as the middle value. So we're going to go like 93 was the forward value, and then like 80 is the reverse value. So even that is a little fast actually, so let's oh, that didn't take. I guess I didn't hit to enter, my bad. So we want 93. Yeah, okay, let's go nice and slow. Perfect. So we're just checking to see if we have enough wire length here. So that'll be the gray and the white wires. And we'll have to stop it because our limit switches aren't wired up yet. There we go. So that's what I was afraid of. Our wires. Oh, that's why. Our gray wire was attached, so it was just locked up there, right on the side of the machine. My bad. So we'll let it go a little bit further. Whoa, that was weird. Huh. Yeah, that's really weird. It seemed like it didn't save the values. Okay. Oh no, wow. Yeah, it's full blast. Very weird. Well, I think we found a little bit of a bug in here. So I'll have to take care of that. I'll have to message DJ about that. But anyways, we got our wire length pretty sure here. Let's try once more. No, we don't want to go this way. We want to go that way. And right when it clicks the limit switch, there we go. That's the amount of length we want. Make sure we have that amount of length. Okay, so I'm gonna probably hot glue that or fasten that up. Get that pinned in there, and then once this rolls back, it'll just make this bunch up inside of the top lid. So, all right, let me take care of that. 1 second. The hot glue gun's already warmed up, so it's perfect. Okay, we'll let that cool down. We'll test it one more time. Once it's cool, we'll go all the way back this way and see if the wires just stay where they're supposed to go. Alright, let's give that a chance to cool. Actually, I'll spread that hot glue around a little bit. Okay, so hook this back up. Not cool yet. Give it a second. So, how was everybody's week? Mine was better now that my daughter got tested for COVID after catching a cold, and she was negative. So it took a little while. It took about a week to get the results back and everything. Well, it only took a day and a half to get the results, but it took almost a week for her to get her appointment, because there's a lot of people getting COVID tested these days. So it took a while. The testing facility that she got tested at was just down the road from us. They could have walked in probably 2 minutes. So we kind of lucked out that way. Didn't have to go far to get tested. So yeah, thanks Nomad. That was definitely some pretty good news. So yeah, other than that, the days are getting shorter. It's getting dark around 7 p.m. these days here. The weather's getting a little cooler. It's dropping down to a high of like 16 degrees centigrade, and then a low of 2. But it's gonna probably drop into the negatives later on this week and this weekend. Okay, cool. Looks like we're ready to test it going the other way. Oh, whoops. That was the wrong way. Okay. I should probably make a note of that the way this is wired, the lower value is to the left. We're looking at the front of this. To the left is a lower value, to the right is the higher value. So I can just make a quick note for myself there. For the x-axis, 76 left, 95 right, 87 stop. Alright, that'll make things easier. Okay, now that we got that figured out, we also have to change some more wiring. I forgot about that. So drop this down. We do have our wire length, so I guess we could put the top on here right away. So let's go back to our wiring diagram for a quick second here. So this one won't have to change because that one is always orange and yellow. It's right here. So it was wired up that way to begin with because it didn't have any limit switches. So we have the gray and the green. That's perfect. And then we have the blue and the black. And so now it'll be white and black, and the blue wire will be for the limit switches. So let me desolder that. I tied this up a little bit, so let me undo that. Alright, and then white will be the new wire, the new white wire. So I have another white wire that's over here, but it's labeled right limit, so that's perfect. I don't have to worry that I got them mixed up. So I will strip the wires here, tin that wire, and then solder it on the board. So we'll be working on with the limit switches pretty soon here. We're going to have to develop a circuit that hooks up to the Arduino that we're going to be putting in here. We'll have to figure that out as we go. We do have our lovely wiring diagram that I created already that you can't really see that well, so I'm going to adjust that. Oh, sorry. We'll do this. Try to keep it on this side of the screen for you. Well, I think that's the best as I'm going to get it. So that's our wiring diagram for this unit. So let me do the soldering of this, and then we'll talk about the limit switches. Oops. I need a set of third hands that are smaller than my Hydra. It's got too many heads, so I never want to use it. Okay, there we go. So I'll just tin the iron here and probably turn this thing off for a little while. You know what? I'll keep it on actually. We might be soldering to the Arduino with the limit switches. Okay, so we have our control for all of our motors. I might, yeah, I think I'll hot glue the wires onto them so they don't break off. They're pretty small gauge wires, I think 24 gauge. So we'll hot glue those onto the boards and make sure they don't go anywhere. We'll have to wait a little while for that hot glue to warm up, but while we wait, let's talk about a few other things. So in here, let's see if I can tilt this right. We have 2 LEDs. So I thought these were just to light up this section in here, but I think one of them is a regular LED, but the other one is a photodiode that picks up on that regular LED. So we might use that to our advantage to do the detection of if the candy has, you know, come down or not. So what we'll need is one resistor to, you know what, actually to test this out, I won't even use an EZB or anything like that. I'll just use a classic coin cell and we'll see what lights up. So this is a trick that I learned from when LED throwies were a big thing, were popular. I don't know if anybody remembers that. Years ago, I guess. Maybe 5 years ago or 6 years ago, LED throwies were a thing. What they were is just a coin cell battery, 3 volts, and a magnet, like a rare earth magnet, kind of like that, and an LED. Actually, let's just grab an LED. And also some tape. So you take your LED, here I'll put it on the screen here for you, and you put it on the battery so that it lights up. Well, this one's pretty dim. Let me grab a better LED. So there's 2 types of green LEDs out there. There's regular green and there's super green. The super green is way better to view than the regular green. So yeah, so the idea here is that these coin cells actually have some ESR. It's called I think it's called equivalent series resistance. And so it won't actually burn out the LED because it can only produce a certain amount of current. Hey PTP, welcome. So yeah, the theory is it won't burn out your LED when you attach it directly to the battery. You don't need a resistor because of the ESR of the battery. And so you take a magnet and you tape this whole thing up and then you throw it. Throw it onto something metal. I was going to say my whiteboard might be metal, but here we'll toss it onto the side of my soldering iron. You ready? There we go. Did you see that? So that was an LED throwy. That was the idea. So you just throw this little LED with a magnet on it and throw it onto stuff, and if you throw enough of them, it looks really cool. And you can kind of light up a little art exhibit or a statue. Crazy stuff like that. Anyway, all that to say is that we can use a coin cell battery. Bring this over here so you can see. To test these LEDs here and see if they light up or not. So I'm guessing blue. Yes, there we go. We have a red LED. Perfect. Okay. And this side, I'm guessing this is a phototransistor. So I'm not going to apply voltage to it. So I'm pretty sure it's a receiver. So give me a second here. I'm going to grab my multimeter and the clips for it. Over here. And we will see if this is a phototransistor, or I guess in this case photodiode. One of the two. I don't remember exactly what the differences are between them, but they do a similar thing. They produce voltage when you shine a light on them. Okay, so we got those both clipped. I'll give you the reading there. It looks like it's reading, here, I'll prop it up so you can both see, like 40 millivolts. This thing is about to, okay. Now we'll use the coin cell battery to light up the LED and see if the voltage changes. Technically, it did. It dropped for some reason. When the LED shines on it, it drops to 0 millivolts. You know, it stays at, fluctuates at like 3 something, and we shine the LED and it drops. So I'm guessing if we pulled this up with a resistor, it would actually pull down once it sensed that the light was there. So it indeed looks like it to be a photodiode. It's interesting that it doesn't really. Yeah, I think this is a phototransistor, if I'm not mistaken, because a photodiode, I believe, produces voltage when you put light on it, and a phototransistor will activate, like, go to ground if you shine some light on it. So that's pretty neat. We will use that to our advantage. Not sure if we'll implement it today or not, but we will at some point. So yeah, I always keep one of these 3 volt. It's called a 2032. So I believe it's 20 is the diameter. I think it's 2 centimeters, and 32 is actually 3.2 millimeters high. So yeah, that's right. That's 2 centimeters by 3.2 millimeters. And so yeah, they're 3 volts, so they'll light up pretty much any LED because most of them have a forward voltage of 3 volts or less. Blue and white LEDs are sometimes at the 3.3 volt range for forward voltage, but it seems like most of them will activate with just 3 volts from one of these coin cells. If the coin cell is new, it's usually around like 3 or 3.3 anyways, but if it's a little older, it'll be like down in the 2.8 range. So just be aware of that. If you have blue LEDs that you're testing out, try to get a fresh coin cell to use with them. And the reason why your LEDs don't burn out is ESR, equivalent series resistance. Okay, so I think our hot glue gun is ready to go. So let's hot glue our wires here. Well, yeah, I was going to mention I have found some artists that I've kind of like started to grow fond of with these copyright lists. There are a few that are pretty common on all these copyright lists, and one of them is called Tobu, Tobu, and he has some pretty good stuff actually. I'm pretty fond of it. And there's another artist called Cartoon, and they have some really good stuff as well. So I'm just putting hot glue on these wires here because they're so small. I don't want them to break off. While I'm here, I'll just put some hot glue on the servo wire side as well. There's also another band called, or artist called Made Monster. I like them as well. They're on a website called 99 Lives. If you ever heard of it, it's a copyright-free website that has just a bunch of like electronic style artists, dubstep and that kind of thing. Here, actually, I'm going to switch the camera view so you guys can see what I'm doing better. I know we don't need to look at the wiring diagram all this time, so let's transition here. You guys can see everything. See my left hand and my right hand at the same time. Alright, enough fooling around. Get rid of this hot glue. Looks like this stuff is cooled down enough to handle. Perfect. Just tuck that in there. I'll make a note for myself on these LEDs and what we found with them. So red, blue wire LED is a red emitter. And then the red, black wire LED is a phototransistor. All right. Just add a tiny bit more hot glue to this one here. Okay, well those cool. Let's talk about these limit switches. Okay, so we'll go back to the diagram for a second here. And you'll notice that all these limit switches have NC beside them. I'm sure those of you guys who've had experience with switches know what that means, but those who don't, that means normally closed. So all these switches are in the position where they're a short, they're a closed connection normally, and when they get activated, when the actual switch clicks, it opens them up. So we'll have to be aware of that when we do our wiring. So let's go to, oh yeah, I guess I didn't know that, and it seems Nomad says in 3D printers that the same sort of idea happens. Okay, so, and I think the reason why they had that is just the transfer power. Normally when you're dealing with switches and robotics, you're normally open. It's mostly the case. So let's go to the whiteboard for a quick second. I'll transfer the view over. And let's see what we're gonna do with these limit switches. Give me 1 second here. Okay, so we have 4 limit switches in the closed position. Red is terrible. Let's use black or something. No, that black is not doing so hot. Cynthium purple it is. There we go. Okay, so this represents a switch. And we connected all of them up on one side of the switch to a common connection. And then the other side of the switch, let's just put another circle on this side of the switch. These switches are usually like this when they're open, and this is representing the switch being closed. And then each of these has a wire coming off of it. Okay, so what we can do, let me sit down here for a second, is that we can do something like this. We can make this a ground connection, and then these are all going to digital pins. We'll just call this D1, D2, D3, D4. Usually should start at 0, but my bad. So I'm going to pull this back a bit. Looks like my 2 is another 3, so okay. And so all of these pins right now would be, sorry, adjust that one more time. Pull it back a little bit, tilt it a little bit. Okay, so we can sense with all these pins that there's a ground connection being made. But what happens when these switches open? So when you have an input here, these are all inputs, looking for that ground connection. If one of them opens, now it's floating. It can't tell if there's a ground or not. So usually in that kind of case, you want to have a pull-up resistor. So you want to have it in a logical state. Floating is not a logical state. You don't want to have your pins floating. So what happens here is we have a pull-up, a weak pull-up. It's usually in the 10k ohm or higher. We pull that up to 3.3 volts or 5 volts. The high side, basically. So you do that to each one of those pins. I'm not going to draw them all, but that's what you do. And so when the switch opens up, this digital pin is going to go to a logical high right away. And if it closes, it's going to be shunted to ground. It'll have a 0 logical low. So that's what we need to do. So on the Arduino side, we're going to tie 4 resistors from each of these digital pins that will be connected to, I think this is like a blue wire. The limit switch wires here, the ones on our diagram here. Let's switch views for a second here. Okay, these wires here. So we got the limit common, which will probably go to ground. We'll have that blue wire, the white wire, and we have these, I think they're labeled R and L, since they're both black. Here, I'll bring the right limit, left limit. So all 4 of those wires will go to the Arduino, and they'll all be pulled up to the high side. I think the Arduino that I have is going to be running at 5 volts, so it'll go up to a 5 volt high. And that's how we'll do it. That's how we will wire these. Yeah, I guess I should have been using this view all along. You can see both. My bad. So that's how we'll do the limit switches. So we'll have to do a bit of soldering on that side. Seems like the music is a little bit high. Tobu, yep, that's that's that artist I was talking about. Yeah, he has some pretty good stuff, but it gets pretty loud, I guess. So, yeah, that will be that for the limit switches. What I want to do now is probably button up the top here, so I don't have to deal with it being open, and I can make everything look a little bit cleaner. And then we will deal with the bottom. And so what we'll do also is probably do a pull-up on the photo transistor. And so while we're here doing some drawings, let's draw that. I'll sit down, make it easier. So we have your LED. Let's do it. Let's do a symbol for an LED. That's your LED, and that's the light coming off of it right here. Usually two little arrows. And then a phototransistor, I believe, is like this. Has two little light arrows going like this to the base of the transistor. And this is the emitter going to ground. And this is the collector, I guess, yes. Almost forgot my transistor terminology, my bad. So this is the black wire, and this is the red wire on the phototransistor. And as you can see, the base has no connection because the connection's being made, activated with light. So what happens here is once the transistor activates, it takes the collector and goes to ground. Makes a kind of like it's like a closed switch. So what we want to do on this side is do the same as those limit switches. We want to pull this up. So I'm not sure what value it's going to be, but we'll start with 10k ohms. And this will go to 3.3 volts. And so when it's not in use, this phototransistor, well, yes, we'll also connect this to likely a digital pin, but we could do analog as well, actually. So let's just say it's a digital pin, like digital 5, let's say. And so it will be in the high state until this LED activates here, and this LED will have 3.3 volts. This will be like a 330 ohm to do 10 milliamps on the theoretical. That's just a rough calculation. You do have to keep in mind the forward voltage of the LED. But and then that goes to ground. So we don't have to have this on all the time. We can turn it off with a digital pin. We don't have to go to 3.3. We can go like digital 6. But I don't think it hurts. I don't think it hurts to have that on. It also can confirm that the whole circuit is working. So tilt this up a tiny bit. So we could do that, but yeah, like I said, this will probably actually just be on the whole time. 3 or 5 volts. One of the two. I'm pretty sure it's going to be 5 volts because it's an Arduino. Hey, Will, welcome. Oh man, it's definitely early in the morning where Nomad is at. Here we're just getting started. We're 8:25 at night, so not too bad. So if you're just tuning in, we were just talking about the phototransistor portion of this here. Of this guy. So it uses a phototransistor and red LED combination to detect if a candy has fallen down here. So we'll use that to our advantage. It'll be part of ours, part of the circuit that we create. So all these wires down here, pull this back a little bit. Okay, all those wires you see there will have to be connected to the Arduino. So we have an Arduino, what's this called? Nano. So this has a Atmega 328 on it. It's got a bunch of digital pins. The nice thing about the Nano is that it has a USB to serial converter on board. Now I hope, cross your fingers, that I have the driver already installed. I don't have to go looking for the driver for this. I believe this is not an FTDI. It's a C H340G, which is a Chinese USB to serial converter. You don't see them very much in North America, but they have a lot of them over there, overseas. So what we'll have to do with this Arduino today is program the firmware, likely from my computer here, since I have Arduino installed in it. Oh yes, looks like PTP says I will need the driver, but you know what, I may have it on here. But let's just do a check. Let's do a test here. Alright, we're gonna take this mini B. Oh man, flying here. Thought all the insects were dead by now. Okay, so we're gonna connect it into the computer over here. See what pops up. Oh no, that's not a good sign. It didn't discover it. Let's just go to our device manager here. Right click on the Windows icon, select device manager, and I'll show you guys what I'm seeing. Okay, let's transition here for a second. Alright, it's our device manager. I'm going to go to COM ports. Look at that. It's there. Yes. COM 12. Beautiful. Alright, so what we can do here is first we go to Cynthium's website and we go to yes, I know. Sometimes it takes a while to install those drivers. They're a little tricky. So I'm glad it's already installed. Okay, products. I think, you know what, no, we're going to go to docs. Getting started, computer I/O. And then here's where all of our Arduino stuff is. This is the same as the Arduino Genuino slash Uno. I'll just click Learn More. Sorry, I can't really show you that, but we're going to go download firmware. Delicious Arduino Uno version. Nice. Okay, so we have the file down here. We're opening it up. We're going to extract it because it's a zip file. I'm just going to throw it in my downloads folder. Okay, if I go to my downloads folder, I should be able to just, I think I have Arduino set up as a default program, so downloads. Oh no, okay, don't. Oh, look at that. Arduino is jumping over on my other screen here, so I'll move it over once it pops up. It's just loading now. Sorry, I have to give Arduino access for a second here. Okay, so we have our firmware here. Now we have to go to Tools, Arduino Nano, and we have to go Tools, Port COM 12, right? Pretty sure it's 12. And then everything should be fine, so we'll hit upload. I guess you guys can't see the progress bar at the bottom, but it's going well so far. You can see the Arduino is communicating, so that's good. And we are done. Perfect. So now this Arduino is an EZB board that can be accessed by ARC. So We're gonna close out of Arduino here. We don't need that any longer. So disconnect from our other EZB here that we were using for testing. Sorry, I guess, you know, old habits die hard. I always use the EZB-V4 for testing. It, you know, when you design something and you get used to it, you know, it becomes a pretty ingrained habit. So here we don't have COM12 on our list. So we're just going to close the connection and add a new connection control, and it should be refreshed. There we go. COM12, perfect. Oh, I'll try it again. Interesting. I don't think this is going to do it, but it's very weird. I think I may have to reboot the Arduino. So just unplug it and plug it in again. After it has like a firmware update like that, maybe I just need to refresh. So let's just double check that it came back up as COM12. We're going to go to our device manager again. COM port 12, yes, okay, we are good. Oh, weird. It does not want to connect. The only last thing I can think of is closing out of ARC, trying again with ARC and see what happens. Now I hope there isn't some issue with this that I may have to enable DTR, which is a possibility. There are some weird Arduino-ish things that happen. Okay, so what we'll do is we'll go into settings and we'll go to DTR enable, save that, see if that helps. Oh, you know what? I think I know what the issue is. I think it's our baud rate. I didn't read the instructions, and I should have. Yep, should have read the manual. Firmware instructions right here. Here. See this? Firmware setup instructions. Yep, completely ignored that. My bad. My bad. Okay. So, look at that. 57600. Easy Ang helps me out. So, let's go change this to 57600. Let's not enable the DTR. And let's connect. What am I missing here? I should have been reading the chat. Looks like PTP was beating me to it. So did I save? Yep, that's saved. EZB0. Save that. We can try DTR enable. Oh! The second time's the charm. There we go. I think it was just the baud rate and me trying twice instead of once. Okay. Now we're golden. We can use this Arduino to control stuff. And unfortunately, I don't have, on the sides of these broken out power and ground, so it'd be easy for me to, plug stuff in. I could do that. I could modify this board. Excuse me. To have 2 rails on either side. You know what? I don't think we'll be using the analog pins, so we could do 2 rails on this side, hot glue them, and then create ourselves a GVS, they call it, header, ground voltage signal header, which servos easily plug into. Because otherwise I'll be having to make another circuit board add-on. Like, this doesn't really fit that well because I've put all the pins, soldered them on the top side, as you can see. Yeah, I jumped the gun on that one. Figured I'd be smart and put them on the top side. Yeah, usually you want to put them on the bottom side for these Arduinos so you can stick them onto an application board. I was, I guess, a little bit hasty. Just wanted the pins on there to test with. So what we're going to do is we're going to convert this into a GVS style header, and we likely won't run it off USB power. I think we'll use voltage in. There's a pin right here on the end, and there's a ground pin right beside it, so we'll plug our voltages in there, and then we'll run those to 2 headers on the side here. Our voltage input for the actual project that comes into the, here I'll show you on the other side. Oh, I was looking at the wrong mouse cursor. Okay, let's go to the work area here. Transition for a second. So this is the bottom portion of the Treat-o-matic, and this is where the AtomicPi computer is. It's actually displaying on this screen right now. Can't really see it that well because of the angle. Try to move it a little bit. The HDMI has been kind of finicky these days. I think it's just the cable is a little worn. I don't know, maybe it pulled out from the back. Says no signal. Try rebooting the AtomicPi and see if that helps. This is actually a PC and a monitor built in. It's got an input. PC mode and HDMI in mode. Anyways, I think the cable might be broken somewhere in there. Worry about that some other time, I think. There we go. Yeah, that HDMI cable needs to be replaced. Okay, so what should we do now? We can work on that Arduino. We can put the top on here. I think I feel like working on the Arduino side, but what I was going to show you over here is that we are using a 5-volt power adapter. Well, seems like I can't stretch it over there. So I'll just move this back a little bit. Of course, HDMI messes up. It's a 5.1 2 amp power adapter. This will be powering the entire system. So the AtomicPi needs about 1.6 amps. It's usually idles around 1.4. Actually, no, I think it's like 1.1 or 1.2. And then when it ramps up when you're loading something pretty intensive, it goes up to 1.6 amps. So we have about 400 milliamps left on that adapter to use servos and that kind of thing. I think that'll be enough because this thing has toy motors in it, so they are not going to draw as much as a geared servo motor. So these are plastic toy gear motors, so I'm guessing the current is going to be like 50 milliamps, guess probably max, maybe to 100 milliamps if it stalls. It might go over, but anyways, I think we'll do just fine. If we need to, we can upgrade this power supply to something bigger. But we'll be running everything off of 5 amps, so this Arduino will also get 5 amps. I mean, 5 volts. Oh, it's not even late yet. I'm still messing things up. So yeah, Arduino will be running off 5 volts. So we have to tap off of actually the voltage input here. Actually, the other side of the switch probably. We'll tap off a couple of lines. Right now we have a couple power lines going to the audio amplifier for the speaker. This audio amplifier, unfortunately, is just not that great. It seems to be picking up a ton of noise. I've been trying to isolate it a little bit. Take the wires for the speaker away from the USB high-speed telemetry wires. That didn't really help. It could be that this is a little it's a cheap USB amplifier slash speaker amplifier slash microphone input. The reason why I'm using this is because the AtomicPi doesn't seem to have an easy microphone input to plug into. It does have audio out. It actually has 2 speaker connections right here and here. Sorry, you can't see them that well. So we use a marker to point with. So here and here, and this whole entire circuit right here on the AtomicPi is actually an audio amplifier. And the reason why I'm not using it is that it requires 12 volts to actually activate. And I just want to run this whole system off 5 volts. Don't want to worry about 12 volts. I could use a 12 volt boost circuit from 5 to 12, but I don't want to. So I could utilize that whole thing. It looks like it's pretty beefy actually. It probably would pump the sound pretty good. But yeah, I'm just gonna stick to my USB. Come to think of it, I'm starting to think about it now. Like I could utilize that. It would be nice because it would likely be nice isolated audio, and I could just run the speaker to here. It's right beside it, so it wouldn't be that far. Now I'm second guessing my choices. You know what? I'll think about it. I'll put it on the back burner for a little bit because I don't like the noise that's coming off of here, and I don't know. I'll have to isolate if it's this amplifier or if it's this this USB amplifier, I guess you can call it. Trying to think. Like, I know the volume was pretty low. I could actually go reference the first hack video when he did this, because I remember the volume being low but not too noisy, and when we added the amplifier, it really noised it up. So I do have other amplifiers too that I can try. So I think next week I'll bring in a couple different amplifiers, and then we'll see if it's too noisy, and then I'll see if I can bring in a boost converter as well to go from 5 volts to 12. I think we'll have to inject the 12 volts onto this, this side over here. This is where the voltage input happens for the AtomicPi. There's a pin header over here, and it has GPIO breakouts and also power breakouts as well. And that's where we're bringing in the 5 volts. So I think there's a 12 volt line in there, and so we will inject 12 volts into there to make it happen. I think there are a couple connectors here too that we might be able to just apply 12 volts to. But really, I don't want to mess around with it. There is this volume header that I'm kind of curious about too, actually. That seems like maybe if I hook up a potentiometer to it, I could control the volume. Who knows? I would have to look at the circuit for the AtomicPi, see how they have things wired up. This is my first time really like doing a project with it, so we'll see how it goes. Okay. Oh, as you can see here, I actually have a microphone wired up. I was testing it earlier today and it works. This is just a common, I think they call them electet. I don't know how to pronounce it. I think it's a electet microphone. I got a whole bunch just from other projects and stuff like that, and salvaging them from. I'm not sure where I salvaged them from actually. I'm trying to think. Maybe old tape decks, because they had microphones in them for recording your voice. Excuse me. Yeah, I think that's probably where I got a majority of them. Anyways, it was pretty sensitive, so that was great. So we will have to test out speech recognition with this little microphone, and we will put it on the bezel that we create. That will be like this guy here. So let me transition over. So that bezel is going to go right in here. But we are going to be designing a new 3D printed bezel that will go in here. I was going to do that today, but I got distracted. Distracted doing some other electronics related things. Next week we'll probably do that. Load up Tinkercad and we'll design this guy. Has a flat panel that goes here with a hole in it for the microphone to go into. And we might even put a readout or display. I was kind of talking about the idea with a coworker Amin here, that it would be nice, you know, if there were people that were hard of hearing that came trick-or-treating and they didn't hear the stuff, the speaking of the robot out of the speaker, it would be nice for it to communicate via a display. So I was thinking about a character display, putting it in here. Now, I haven't done much work with character displays. I think the best bet would likely be like a USB to serial character display and then send serial data to it, or an I2C character display. But I don't know if DJ implemented I2C yet on these guys, the Arduinos. I'd have to refer back. Anybody remember if he has done that yet or not? I could just load up the... Yeah, just give me a quick second. I'll load up this for... Not that. I'll load up the Arduino code for a quick second, and we'll see if I2C is in there. Downloads. That way we can use... Oh, okay. PTP says not implemented yet. Yeah, serial. I don't think it says anything about I2C here. UART. Oh, wait a second. Here we go. I2C clock speed. So let's do a Control F and see if there is any other mention of I2C in here. SDA or SCL. I2C write, I2C read. So they're defined. They might work. If DJ was watching, jump in the chat and tell me. Or next week we will find out. I hear DJ might be coming back next week. That's the rumor. Don't hold me to that. I'll just control F and see if I can find SDA for a quick second. Nope. So possibly there. I know he was talking to somebody about it a while back on the community page. But yeah. Anyways, let's not dwell on that too much. Let's do some hacking of this Arduino. So I'm going to move the big boy out of the way. So we're going to do black and red colored headers on the sides here. And with the order we will use is red and then black on this side. And so the reason why we do that, have red in the middle, that's your plus voltage in the middle. And so if you connect something backwards, all you're doing is swapping the ground and the signal wires. And that won't really do much. You don't really want to have red on the outside because you'd be swapping positive voltage in the signal wire, which the logic of the servo that you're using might not accept a high voltage, and it could blow up your servo electronics. So that's a design consideration to take. We'll try to match up all these pins. We just snap those. Looks like 15 pins. This is how my little trick to lining these up, so I don't have to count them. Just do it once and then break them off. Okay, so we'll hot glue them to the sides of each other, and then we'll run some wires over, and then we'll put a bare wire across all those so they all have the same voltage going to them. Alright, hot glue time. Now the hot glue is going to squeeze out the top a little bit. But I think we can take care of that with a flat blade screwdriver after we're done. Okay. It'll take a little while for that to cool down. We'll put on the next header. Should probably be a little bit less generous. So we have so much hot glue going everywhere. Line those up. Okay. Kind of wait for that to cool down. and maybe bring you guys in a little closer so you can see what's going on here. Get some wires out here. I'd like to find some solid core wire. Should make things easier. Well, I know that. So here's a little simple test. Here I have some Ethernet cable, and the way you can find out if it's solid core or not is simply just do this. If it stays in its shape, the shape you bent it in, then it's likely solid core. Pretty sure 100% it's going to be solid core. So I don't know if this is going to be a thick enough gauge though. That's the struggle I'm thinking of. You know what, we'll double it up. So I'll just fold it over itself. So I'm just going like this lightly to score the shield, the sheath. Pull that off. So we'll have to be at least 2 lengths. So one thing with most multi-conductor cables is that they have a, now I wish I knew the term for this thing, but I don't. Somebody in the chat definitely throw that in there if they do. But this string is not just for flexibility of the wires, but it's also for peeling back your insulation easily. See, that makes it pretty easy. So if you didn't know that about multi-conductor wire, now you do. So make sure that we have enough length here to be folded over. Okay, that's good. So we're gonna have to get bare wire here. You don't want to try to melt the stuff because usually, pretty sure this stuff has Teflon coated wire on it. Double insulated actually. You see like this just peeled right off the first layer of insulation. So hopefully I can peel this off without too much trouble. Seems bunched up here. It's not going so well. Use the wire strippers. 24 gauge. There we go. I bunched it up too much, I guess. There we go. So here's our bare 24 gauge copper wire. So this will be our bus bar, we'll call it. And that will go along the positive voltage edge, and we'll make one for the negative voltage as well. So this looks all right. So let's put this guy on. Try to use my pliers to kind of squeeze it in place. We don't want to short anything out. Actually, I don't think I'll use my pliers, I'll use my tweezers. Make things a little easier, I think. The idea is that maybe I'll make small circles by tweezing these around each pin. Just having a hard time with it staying in place. Maybe we'll focus on the end first. You know what? I don't think these have enough power to close. Let's try these guys. Seems to be working. I think what we'll do is solder the first one, and then this thing won't move any longer. Okay, I've got a tack soldered on there. So do I have any heavier duty? Yes, okay, this might work a little better. It doesn't seem to be working any better. So I don't know if you can see that, but that's the way I've started. Doesn't look all that great. Let's see if I can get the one side pushed all the way in beside that row of pins. There we go. And then maybe we'll just kind of force it around each pin. I think a screwdriver might help a little better. Yep, that's doing the trick. You know what, hack nights are not only about making stuff, but definitely learning about stuff and learning new methods. Tonight is definitely one of those nights. Okay, so I'm gonna solder on that wire down in this area near the middle point, so that it's not going to flex out again. And then we'll solder it down here at the end. Oh, hot, hot, hot. Who would have thought that it would be hot? Alright, so it's not close to the black wire or the black pins, so that's perfect. So I'll start soldering this rail, we'll call it the voltage input rail. Now I don't want to put too much heat to bend these pins. I want the pins to stay in place, because they can definitely go all over the place if you let them. We'll use our metal bottom plate, so that I've had it in the past where the pins will melt through the rubber mat, so I don't want that to happen. So what I'll do, so I don't get too much heat in one section and melt stuff, is go here, 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 and kind of trade off. There's a pretty large blob I laid down there, so I'm going to try to spread that to the next pin. I also don't want to melt the hot glue. Oh yeah, the hot glue is melting along the black edge there. I'll just wait for that to cool down a little bit. While we're here, I think we'll make a small hook. We'll twist. So make sure that nothing's going to be affected by this, but we'll twist these together. Oh, that's what I thought. The hot glue is still soft on both edges. So we'll just wait. Let that cool down a little bit. So on this side we actually have D0 to D12. So 13 pins. I don't know if we can actually use D0 and D1 because they're the TX and RX pins. Probably leave those alone. Okay, it seems like it's cooled down enough. So we're gonna trim this down, make it into a small-ish hook so that we can hook the wire that comes from the V-in port right onto here. And while we're here, we can prep the next wire as well. We bunched it up again. Because this is double insulated, that's what I think is causing the issues. Okay, there we go. All stripped, ready to go. So we'll finish soldering up this red wire. Oh, it's interesting, and none of the solder went on to the inside cable that we have in there. We definitely want as much surface area on that wire to be soldered on as possible. So I think I'm going to have to force my soldering iron down into there a little deeper to actually get that stuff soldered in. And for some reason it wants to bridge with the digital pins. That ain't cool. One thing to fix solder bridges, I don't know if you can see that. You can see this area is all bridged together. It is just adding some flux. So I'm going to add flux everywhere. We'll make the solder flow a little nicer. Okay, now it's all fluxed. Just heat up that spot again. And then, yeah, just wipe it away. There we go. Just touch those up a little bit. Okay. Oh no! I got so much heat on it. The hot glue is trying to melt again. Trying to free itself. Well, we'll try to stay at this end then. Okay, we'll let this side cool down a little bit, and then we'll work on this side. Okay, the whole thing is now a big blob of solder. I won't pick that up because it's still hot and the hot glue is melted. But take my word for it. Maybe I can pull you in a little closer. I don't know how well it'll focus in on that. But you can see this rail here is entirely a dull gray, which means they're all soldered together. So we'll do the same thing for the ground. And you know what? I think instead of going on either side of the ground, we're just going to stick to the one side. I think it'll be so much easier. Just go like this. Okay, let's start on the ground side. We've tack soldered part of it on. Oh, still warm. You have to be careful. I'll tack solder it on the other end. Ooh, that's hot. Hot on the fingers. We'll use the tweezers. Slippery guy. Oh, I didn't wait long enough for that to take. Creating a very cold solder joint here, I think. Yeah, this is so cold of a solder joint, so let's use some flux and make it happen here. Okay, good. Okay, hopefully everything is still in order. Yep. Okay, let's use our trusty screwdriver and bend this wire near to the pins. Okay, I think it's close enough. We'll put a bit of flux on there, make sure everything just flows really well when we solder it and quickly. Just don't want to warm up that hot glue too much. Okay, I'll solder it in the middle first. Just want a lot of that solder blob to stay on there. Cool. We'll kind of do this in thirds. Oh, it looks like our solder joint released at the top here. Woo! Things are still hot. Yeah, sliding around. Want to get a lot of solder on there so that we don't have any pins that are not connected. I'll let that cool off for a little bit so I can see the hot glue starting to release. Okay. Alright, what can we work on while we wait for that? Well, I was thinking about the limit switches. We could put headers on each of the limit switches so that they can plug onto here really easily. And in between, we also need another connection coming off of each limit switch. So here, let's switch our view here. Okay. Okay, so right here we'll need to put a connector to connect to this Arduino, but we also need a pull-up resistor to go to positive voltage. You know what? We could easily bridge a pull-up resistor to go from the digital pin to the positive rail, because we'll be using 5 volts as the positive rail, so it should be completely fine. If we put little surface mount 10k ohm resistors across, and then just put on the actual Treat-o-matic side, the wiring side, just put a simple DuPont connector on them, female DuPont, like this. Just kind of cut these in half and splice them on to those wires, and that should be good. It also makes it easy for the photo transistor as well. We'll just make a pull up that goes across there. I'll show you what I mean. Alright, so we got some 10K ohm surface mount resistors here. 0603 style. I kind of made that a standard for myself. I started out with 0805 sized surface mount components, but then I thought I could save a lot more room and make smaller circuits with 0603. I didn't want to go down to 0402 because you get down that small and it's like you can't do anything without a microscope. At least these you can see with the naked eye and manipulate. So we're going to probably start at D2 and move up from there. So this has TX, RX, reset, ground, D2. So 1, 2, 3, 4, 5th pin. 1, 2, 3, 4, 5 right here. So we'll start right here, and then we'll do 5 of these resistors going up there. One, 2, 3, 4, 5. Sometimes it's hard to see if you actually soldered those guys or not. But I do have a loop, which is kind of like a small microscope, a jeweler's microscope. Magnifying glass, I mean, not microscope. I do have a microscope as well, electronic microscope that we can use. I think we'll reflow these after with some flux, just to make sure. All right, one more. All right, let's reflow these solder joints. Oh no, the hot glue's trying to get soft on us. That hot glue is getting real soft. Oh no. Okay, I'll let that cool down. I put a ton of flux on that thing, so I might have to clean that up after. What our 10Ks are now placed. 5 of them, pull-ups for our limit switches and the transistor. So let me clean up a few things here, get them out of the way. So we'll have to do some soldering of these guys too on the Treat-o-matic. So we'll move this aside so it can cool down. And we'll give us some more surface area that we can see. We'll also need a series resistor for here, let me change the view here. We'll need a series resistor for this LED in particular. And we might just use like a 3-pin style DuPont connector that will go from 5 volts to ground with that resistor in place. So we'll just use like an old servo wire for that. I think I have some kicking around. Yeah, there we go. Old servo wire. We'll take out the center wire. Actually, what we'll do, so those wires stay together nicely, I'm going to take the outside wire, strip that away, and then we'll use our tweezers here to pop it out. Okay, almost there. There we go. And then we'll push that tab back down in there. And we'll free up the center tab. Pull the wire out of there. And stick it on the outside. Beauty. So we'll splice these wires together with these ones, or I could probably solder directly to the connections actually. I don't have to splice. That'll make things easier. And we'll put a resistor on, doesn't really matter which side, but we'll put it on the positive side. Get myself a through-hole resistor, 1 second. So I'll make it easy for myself and tin these wires and then create little hooks on them, or at least one of them. Yeah, put a bit of solder on them so it makes the wire hold its shape like that. And then I can do the same on the resistor. And make a little hook, and then just squeeze them together. Of course, that's not a good enough connection, so we will solder that as well. Just holds it together nicely. Okay, so let's see if we can peel this hot glue off and get at these connections in here. There we go. Desolder these wires off here, starting with the red wire. There we go. Red wire top, remember that. Ship in a bottle here. Okay, hold that there. See if I can solder with one hand. Maybe two hands. Boy, definitely awkward when you're holding something at the same time. There we go. Okay, I'll make a little hook on the negative side, the black side. Okay. Solder that. After we're done this solder job here, I can show you, well actually after I'm done the Arduino solder job, I can show you guys how it's gonna fit together. We'll add some more hot glue on there to replace this stuff we took away. Ooh. It's going all over the place. Alright. Let's bring the Arduino back. I'm finishing up soldering on it. Okay, I just need to finish off these black pins here. Just a few of them. Seems to be tipping over a whole bunch. See if I can just use the tweezers to hold it. There we go. Okay, we'll finish off these pins and we can do some testing here. Oh yeah, I forgot, we're going to have to bridge those connections from ground and V in. Twist these guys together. Trim it and make a little hook. Two little hooks to solder to. Okay. Grab some wire, make those connections. There they are. Lost my wire strippers for a second. So I'll tin these, and then I'll hook them up to those hooks that I made, solder them on, and then solder them to the connections that we'll be making from the V-in line and the ground line. I might have put a bit of heat shrink over top of that connection so it doesn't bend and touch the other connection. Yeah, sorry, this is probably kind of a boring process, watching me just solder stuff. Yeah, it's stuff that needs doing. Okay, so I'll put two little tiny pieces of heat shrink over top of that. I have to stretch this piece of heat shrink out because it's just a little bit too small. So yeah, if you don't have like the size of heat shrink that you need, you can stretch it. I've done that many times over the years. I've had a piece of heat shrink that's just a little bit too tight, stretch it a little bit, put over something larger, or stick your pliers in there and stretch it out a bit, and then it can fit over your connection. Just using some hot air to shrink those wires. Okay, and so V-in is this first wire, and ground is the second. So try to bend it so that V-in takes the inside path and ground takes the outside path. So just need to take a tiny bit off strip a little tiny bit off and bend that into place. There we go. It's the red wire. Solder that on. Our V-in connection is made. Perfect. Now we're going to bend this black wire along the edge here and then come in and hook around and solder on. Just enough length. Okay, so I'll have to hold that wire while I solder it, because it seems to be springing out of the way. Actually, maybe I'll just... I think what I'll do is pre-solder it, tin it. Oh man. Insulation really let go there. So it's going to tin it so I can make a little tiny hook there. There we go. Ugh. We've done it. Now we should check with our multimeter, just in case, to make sure that nothing is shorted out. We do not want to have the positive and negative rails shorted. Would not be good. Let you guys see the reading here. Looks like 18 mega ohms or kilo ohms. Can't see because of the glare. $19 mega ohms. Yep, I think we're good. Okay. So, oops, bent some pins while we were at it. So I wonder if 5 volts will show up on the V-in pin. Let's see here. If I plug it into the USB. Okay. Kind of. It's 4.49 volts. See the 5 volt pin. 4.9 volts. Oh, weird. The V-in, they must have a diode on there that protects the 5 volt line from the V-in line. Okay. So we'll clean up the flux a little bit. You know what? This is no clean flux, so it probably won't. Because if I do use alcohol on this board, it will free up the hot glue as well. So, if you haven't seen that before, we've talked about it in live hacks a few times, that hot glue will release the surface tension of the, or sorry, alcohol will release the surface tension of the hot glue and it will peel off. Oh yeah, when I mentioned I2C, I was thinking about putting a character display on this section here. I was thinking about I could do an I2C character display. Or I could also do a serial character display as well. Okay. Now we should probably splice in some of our DuPont connectors onto some of these guys. And we should probably trim some of these guys a little down a ways because they don't have to be that long. So, you know, we could test something right now. Test a servo motor on D. What doesn't have a resistor pulled up on it? D7. And I don't know, powering a servo from the USB of your computer, probably not recommended. Maybe I won't do that. So the one thing we will have to be aware of is that we will have to power this board with external power for the servos. Well, I guess they're servo motors now, but the motors that come on this guy. And we'll also need a USB connected to the board from the AtomicPi itself for communication. So we might want to do some trace cutting or take the 5-volt regulator off this board. Yeah, that might be the best bet. Remove the regulator, and then we know that everything is isolated from each other, and just apply voltage to the V-in, which will be 5 volts. You know what, I might worry about that later. I think it's getting to the time where I'm starting to power down. I'm getting to be slow, Jeremy, instead of regular speed, Jeremy. I don't think I have a fast speed, but I get the job done still. Efficient speed, let's say. I don't have a boost mode. Oh, unless I drink a lot of caffeine, and then I'll probably get into a boost mode. Really fast talking and that kind of thing. I could, potentially have some caffeine right now, make things go a little faster, but it's getting close to bedtime, and caffeine and bedtime don't mix very well. I think I'm going to start winding down. I think we're going to leave it at this stage here. Didn't get to everything I wanted to test today, like getting the microphone and stuff, getting that all figured out, getting the bezel here completed. But I think that I might just put some time and effort into it during the week to get some of those things figured out. Yeah, I think I'm done for this evening. Thank you to those who bared with me during the technical difficulties of this live stream, and thank you for being involved in the chat as well. That's awesome. Thanks for keeping me company. thanks for enjoying the project as well. And I think we'll tune in again next week. Here, let me switch things up for the view. Here we go. So next week, we will likely start doing our programming after I get the hardware portion completed. Putting the top on this guy, it's going to be pretty easy. Just a few screws. We have the wire length set up, ready to go. That's all tested. And I guess we will still have to do a little bit of soldering down here for the phototransistor and these wires. I might try to do that on my own time. We'll see. Don't want to have that just be, turn into this hack where I'm just soldering a whole bunch. I didn't even realize I had that much hardware to take care of this round. I will also have to figure out that amplifier issue, get that cleaned up. I'd like to have it sound a lot better than it does. And I don't know, it might be too much to put a character display on here. We'll see. We'll see if I get inspired or not. Yes, definitely we want to put a camera. Excuse me. Here, let me have a drink for a sec. Yes, we want a camera on here and a passive infrared sensor as well. I think I have that in my bin. I have a couple of those things. The reason for the camera is to detect faces or detect motion. We do have the USB. Here, I'll disconnect this. Oh, sorry guys. Just pulling things apart over here so you can see better. So here we go. We have this, right here is the only USB jack on the AtomicPi, and that goes under the board and comes out right down here to this USB hub. So right now I have my keyboard and I had my mouse plugged in, and yeah, that's actually one thing that I wanted to do today, but I forgot about. But I'll figure it out probably during the week as well. Is I want to remote into this PC instead of having to hook up a keyboard and mouse all the time and monitor, so that yeah, I can just easily update it and not have to have a whole bunch of hardware hooked up to it, just from my laptop. And I'd like to make that happen. I was thinking about using tight VNC, but I was talking to Amin, and he had mentioned, hey, you could just use remote desktop. They're both Windows computers. I was like, well, pretty good idea, actually. I've never used remote desktop, but it's native to Windows. I don't have to install any extra software, so that would be handy. And so I'll probably use a USB camera. Yes, I will, because we're using this guy instead of a EZB. EZBs can have the cameras attached to them, but we're just using this little tiny Arduino. So we'll probably mount it, around here somewhere, likely, or like this, so we can get a USB cable over to it, and then all of our motors will be plugged into it, as well as our limit switches and our LED and transistor. And yeah, we'll have to have a couple of power lines going to there too, going to V in and ground to power the whole thing. So yeah, a bit more hardware to go. I hadn't really thought that there was that much more, but there is. So I think there's enough for another live hack worth of hardware changes and stuff. But yeah, I'll try to put in some time on my own time. Yeah, I do have a USB camera. Actually, it's fairly small. I'll I don't know. It does have LEDs built into it, so I'm not sure if I want to use the LEDs or not. It can become really small if it doesn't have the LEDs, or nice and bright if it does. Here, I'll show you. Alright, this is what it looks like. So if I pull it apart, it could be pretty small. You can see the screws in the back. Should be pretty easy. Actually, it doesn't have any screws in the back. I think it just all fit together. But it also has this guy here, this dial. Here, I'll turn it so you can see it. To brighten the LEDs or get them dimmer or brighter. So it could be handy for Halloween because it's at night. It would be nice to have some sort of light to project on people's costumes or their faces to see if we can detect faces. I'm not sure if that's a good idea or not because people will likely have masks on, so it could detect a mask probably if it has eyes and a mouth. So we'll take the stand off of this thing at least. It doesn't need the stand. So it could be a little bit smaller. Nomad had mentioned if we put it on the top of the robot, we could have like a pan and tilt scenario, and have the camera follow people or kind of get into the proper position to see their face or mask, whatever the case is. We'll see. Yeah, I guess that's the other piece of. Yeah, the camera could be mounted inside or outside. Not really too worried about it. I could put it in that bezel section right here. Or, I guess you can't see that right here. Or not. I think I'm leaning towards or not. I think I'm going to possibly... I don't really want to put it at the top because the thing is I would have to run the USB cable down through and into the bottom of the unit. I could go from the back of the unit, I guess. From the back through and up and around and onto the top. I'll do some thinking about it. How about that? Or you guys think about it and tell me if it's a good idea or not. And we'll go from there. Like I said, thanks for coming around and joining on this live hack with me, and we'll see you next week hopefully, and we'll make this thing come to life pretty soon. A little bit more hardware work on it, and then we'll start on the software, which I think is going to be fun. We'll use Bing speech recognition likely, and maybe do our own chatbot, I guess. We'll see. I forget which skill it is. It's not Pandora bots, but there's another one there. You can do your custom chatbot. So yeah, take care, you guys too, and have a great weekend. And thanks again for joining. We'll see you next time.